Okay, last two. Alright, our u substitution. My first choice would be to do e to the 2x because it repeats and looks like a good choice. The problem is when I go through and I actually tried e to the 2x, I kind of ran into a hole. Again, I kind of like to show you just so that you can see when to stop, when to see that your u sub didn't work. So don't write this down, but e to the 2x was my first choice. So the derivative du dx would be e to the 2x times 2. I had to multiply it by 2 because of the chain rule. So I'm looking at du dx equals 2e to the 2x. And when I'm solving for dx, I would get du over 2e to the 2x equals dx. Coming over here, I would have the integral of u over u plus 4. And then my dx would be du over 2e to the 2x. Looking at this problem here, e to the 2x is actually going to be a u. So let's look at that. So do you see that this u and this u would reduce? So that's nice. And this 1/2 could be pulled through. So I'm looking at this. But here's the problem. How am I going to integrate 1 over u plus 4? That's impossible. I can't break that up. I can't use my neon sheet. I don't have a quotient rule. So in the end, I'm forced, dead end, stop. I have to pick something different. So I'm going to erase this, and I'm going to pick a different u. And the only other choice that I see is the whole denominator. So let's give that a shot. You just have to be patient. Don't force things to work when they don't. Du dx is equal to, again, e to the 2x times 2. So it's the same derivative because the derivative of the 4 turns to a 0. So du dx equals 2e to the 2x, which makes du over 2e to the 2x equal dx. Coming over here, this does help a ton because now, what is my substitution? Well, I'll have e to the 2x still in the numerator. My whole denominator becomes the u, and dx over here becomes du over 2e to the 2x. And you can see now this time there's no dead end. E to the 2x, e to the 2x reduces. The 2 here will pull through as a 1/2, and I'll be integrating a simple 1 over u du. And that's a lot better how that worked out. So I have my 1/2, natural log of the absolute value of u. If you don't mind, I'll just sub that in right now and add my c. And there's my answer. Okay, last one. Okay, we have the integral of sine cubed x plus cosine squared x plus dx. Okay, so what should we pick this time? Okay, so let's use some logic. Cubed is tough. We don't have anything really. Our identities are all squareds. The derivative of a sine is cosine, cosine is sine. Of course, we have negatives in there too, so they'll both, if I pick one or the other, they'll both bring a degree down because the denominator will show up. So my logic here is let's tackle the cubed. Let's go through and let's let our u be a cosine. Let's see if this works. The cosine of x. So du dx is the derivative of cosine is the opposite of sine, okay, which we picked on purpose so that this will go to a denominator. So I'm going to solve for my my dx. What am I doing? Okay, so solving for my dx. So I have du over negative sine of x equals dx. Okay, now that I have this, I'm going to put this over here. We have sine cubed of x, u squared, du over the opposite of sine. Okay, so what's going to happen is I can reduce this with one of those. I'm going to keep the negative outside, so I'm looking at sine squared x u squared du. Okay? And then now that I'm here, what can I do to turn my x's to u's? So the reason why I chose to tackle the cubed is because I thought if I could at least get to squares, I have my Pythagorean identities. Sine squared plus cosine squared equals 1, and so on. So let's think about that. If I have sine squared, and we know that the sine squared of x plus the cosine squared of x is equal to 1, doesn't the sine squared of x equal 1 minus the cosine squared of x? Okay, so I'm going to take that and sub this sine squared out and make that a 1 minus cosine squared of x, u squared du. Okay, the only thing that I did here was turn a sine to a cosine by using the identity. And now I'm thinking, the problem is this is an x and it needs to be a u. Well, does it u equal the cosine of x? So, 1 minus u squared, true? And that's going to do the trick, because now I have all my u's. I can distribute this u here, the u squared. So I'm getting u squared minus u to the 4th du. And now I can finally take my integral. So again, this negative, keep that out here, and let's integrate u to the 3rd over 3 plus, or minus, u to the 5th over 5, and then we have our plus c, which you can put, the negative won't affect it, because you don't know if that's positive or negative in the first place. Okay, so that's us integrating, and then our final step will be to sub that back out. So our final answer should be, let's distribute at the same time. We're going to do a negative cosine cubed of x over 3 plus a cosine to the 5th power of x over 5. And then you could put plus c or minus c. We could not take off for that because that's just going to end up being a constant, like I said. And in the end, it doesn't matter if it's positive or negative. Because you don't know what it was in the first place. Okay, and that way you can see your final answer. Okay, so that's it. That's your last example of the same type of thing. That's u substitution. I know that it was a long lesson, a lot of examples. Hopefully this ends up breaking up into 2 days for you guys. But remember, big tip is just don't get frustrated, and if it doesn't work, then just try something different and just keep playing with your u subs until something works, and be creative, okay? The harder ones are going to be the hardest ones on the test, so don't worry. Like, I can't give you all hard questions on the test. So you'll get it. Hang in there, work hard. I'm proud of you, and I miss you guys. Bye.